Welcome to Science Power Hour, the podcast where we break down the science of teaching science. I'm Heath Belcher, your guide on this journey through the fascinating world of education, innovation, and all the things you need to know to inspire the next generation of scientists. Whether you're a seasoned educator or a new teacher just setting up your lab, we've got you covered with tips, tricks, and insights that will make your classroom a place where curiosity thrives and students shine. Hello, science teachers. It's great to have you here for episode 3 of Science Power Hour. I'm your host, Heath Belcher, and today we're diving into science and engineering practices in the classroom. On this episode, special guests from the Stile digital teaching platform will help us better understand how to apply science and engineering practices in our science classrooms. No longer are we asking students to simply memorize facts or regurgitate definitions. Instead, we're challenging them to think, act, and solve problems like real scientists and engineers. But with these changes come new approaches for us as educators. Whether you're navigating the latest teaching trends, looking for creative lab ideas, or just need a little inspiration to keep your passion for science alive, this is the place for you. In this episode, we'll explore the specific adjustments science teachers need to make, from fostering inquiry-based learning, where students ask questions and investigate, to designing lessons that emphasize hands-on problem solving. We'll talk about strategies for encouraging collaboration, teaching students how to analyze data, and build their skills in constructing explanations and designing solutions. So, grab your coffee, your lesson plans, or your safety goggles, and let's get started. Welcome to Science Power Hour. I'm Heath Belcher, the Associate Superintendent in Lincoln County Schools, and today we are excited to have some special guests with us from Stile Education, and we're going to be talking about the next-gen science standards and the science and engineering practices, and we've got some experts who have developed some curriculum resources to help us implement these resources. So I'm happy to have Gentry and Mark Picardo with us today. So welcome, Kat. Welcome, Mark. If you would, just tell us a little bit about yourselves and kind of your background and what your role is with Stile Education.
For sure. I can go first, Mark.
Go ahead.
All right. So my name's Kat. I'm the head of Stile USA. And my background is in teaching and research. So I was a science teacher in a tiny school in the middle of the desert in Australia. And then I went into academia and started being a scientist, essentially. I studied salmon aquaculture and how to make it more sustainable, looking at parasites in particular. But for me personally, I was kind of shocked that I kind of found being a scientist easier than being a teacher. And that kept me up at night. I was like, there are millions and millions of teachers going to the classroom every day. And they have relatively little support and relatively few resources, but they're doing a really good job. But what is something like I could do to try and make science classrooms more engaging, more effective, and more fun, both for teachers and students. And this really kept me up at night. I just kept dreaming of schools and being back in the classroom. And that's ultimately what led me to be at Stile. And I started in the product team, building a lot of the product that now exists in our curriculum before moving over to the US about 2 years ago, where I now lead the team, of which Mark is one of our key members. Over to you, Mark.
Thanks, Kat. Yeah, I'm Mark Picardo. I am North Carolina's science education leader for Stile. I come with a little bit over 10 years of experience in education, both as a teacher and an administrator. The majority of my time in the classroom was in special education in New York, but my family and I moved down to North Carolina about 18 months ago, and I am actually a former Lincoln County educator. I was an EC teacher at S. Ray Lauder, so shout out to the Lions. But my experience and my trajectory has brought me to a point where I am ready to bring something that is wonderful and amazing for our teachers. I see every day the challenge that our educators and our leaders have in finding a curriculum that is impactful. And so I'm really excited to be with Stile now and hopefully bring something to your teachers, Heath, that is going to really be amazing for them.
Fantastic. And so, Kat, I'm going to ask, because I know our listeners are probably wondering, so just to get kind of personal for just a moment, is there really any difference with science education in the U.S. versus Australia? I mean, what does it look like? What are some of those differences that you've kind of experienced since coming over here to the U.S. a couple of years ago?
Such a good question. It is completely different and completely the same all at once. The science content, what in the NGSS you'd call the disciplinary core ideas, that stays the same pretty much across the two countries. But there's different emphases. Certainly, every state in the US, I think you're going to need some local context to be grounding any scientific phenomena in. And that's definitely the case when you look at the standards that are in Australia and the standards that are over here. There's a lot more emphasis on, marsupials and monotremes in Australia and the weird wildlife that we have over there. And similarly, over in North Carolina, you're going to have Lake Norman, you're going to have Venus flytraps, all part of that sort of grounding part of your science standards or your science classroom. But then ultimately Australia isn't following the NGSS, so the science and engineering practices and the cross-cutting concepts are not part of the Australian curriculum. There's similar threads to the Australian curriculum. There's scientific skills and there's science as a human endeavour, but they're different, and that means that Stile's had to produce a different curriculum for the US.
That's great, and hopefully we'll have a chance maybe to talk about some of that local context that you've referenced for us here regionally in the southeastern part of the United States, and some of the local curriculum options that Stile perhaps has for that regional context. So Mark, and probably the same question for you, New York, North Carolina, what's it like? What's the difference, similarities? What have you experienced?
That's a great question. It's funny because I think if no matter where you go in the U.S., everybody is going to say, "Oh, it's the curriculum, the schools are so much different." The reality is, as soon as I came down here, teachers are teachers and kids are kids, and whether you live in New York or North Carolina, good teaching practices are what they are. I would say the students are a little bit happier down here because we're not dealing with the snow and the bitter cold, but no, in actuality, I was really pleased and really happy to see the rigor and the dedication that the teachers have in the public schools in North Carolina. I would say, especially with the lack of resources that some of our schools and our teachers have in comparison to a state like New York, it even highlights how much more dedicated our North Carolina teachers are to their students and their craft, and how they will go the extra mile and that next step to do what's necessary.
Yeah, that's a phenomenal reflection when you think about kids are kids. And so when you even, like a child who is inquisitive, a child who wants to have fun while they learn, it don't matter if you're in New York, Australia, or where you might be, that language is universal. And it's just a common truth, I think, that we see in all of our classrooms. So I appreciate taking time just to share that little bit of background with us. And so kind of leaning into that a little further and building on that, what inspired the development of some of the activities that we would see in the curriculum that Stile offers whenever a teacher first takes a look at a lesson plan from Stile or at a unit plan? Where's some of that inspiration come from?
Yeah, I can speak to this, and feel free to jump in, Mark.
Absolutely.
I feel like there's kind of a few layers to this. I think where Stile starts with everything that we build is our mission, which is a world-class science education for every student. And so there's, that emphasis on inclusivity. This isn't about creating a curriculum that only kids who are going to be career scientists are going to be interested in using. This is about creating a curriculum that's going to bring all of our kids along on that journey. And as a result, you will see a bunch of sort of accessibility features and inclusion pieces to the way that Stile is built. So that's kind of the overarching premises of everything we do, this high quality inclusive curriculum. And then if we sort of go a layer down, the way that we go about that is by empowering teachers. We think and we know that research shows that teachers are the most impactful thing that can happen to a student in school. And so if we can, really support our teachers to focus on what's most important and take away some of the extra load that's on their back when it comes to maybe assessment or lesson planning or everything in between, they can just focus on building those relationships or focus on, finding those local phenomena, finding those really personalized pieces that are going to catch students' interests and latch them on, then we think we're doing a good job. And if we go that sort of layer deeper into what we think a great unit or a great lesson looks like, we're always going to be looking for a great mix of modes, so print, digital, and hands-on. We sort of aim for a third across a unit. And part of that is because we know every student in our classroom is going to suit different modes of learning at different times and probably have preferences as well. And to be able to reach all of our students, we need to make sure that they've got a whole variety of ways to access that information. So we're really looking at, print, digital, and hands-on ways to enter the lessons. And then when we're looking at a lesson itself, we're really thinking about the 5 E's. So we're thinking about, or the unit as well. We're thinking about the engagement, the exploration, all the way through to that evaluation. And so that's kind of some of the high-level pieces that we look at. Did you have anything to add, Mark?
Yeah. So before we started, Heath, we were talking a little bit about the portrait of a graduate and the significance that is to our North Carolina students and educators. And we talk all the time about how Stile is producing a curriculum that's going to help our students solve the problems of the future. And I used to love to teach my middle school students and talk to them about how the jobs that we're preparing for don't exist yet. We think about the job market and the way that AI has evolved and technology has evolved. In a lot of ways, our students are preparing for positions in the workforce that are not yet created. And so in addition to the fact that Stile is so aligned well with the North Carolina science standards, but also those soft skills, that collaboration, that communication, problem solving, the way that we're presenting and communicating information, I really feel strongly that Stile does such a great job at engaging students in those soft skills that not only are our kids going to walk out of that class with a really great understanding of those science concepts, but also with skills that they can transition to all of the other core content areas and bring with them as they transition through their K-12 and collegiate experience.
Yeah, totally. So I just immediately think of our Socratic seminars where kids actually get to research a topic and take on a perspective that isn't theirs and then debate it and coach each other on becoming stronger debaters.
Yeah, and so if we think about even that example of a Socratic seminar and the idea of the role that questioning plays in a science classroom, asking those driving questions, those big questions, and then being able to have student-led conversations about those. So what does that look like within Stile using that question format, that anchoring phenomenon that you're examining and exploring? And is there a particular lesson that stands out or that comes to mind where that's really evident? And so if a teacher were like, I want to see that lesson plan that they could flip to or go to learn more.
Yeah, for sure. So every unit in Stile is going to start with a driving questions board lesson where students sort of introduced to the guiding question for the unit, and maybe there's a little video or a little phenomenon that they get to sort of explore a bit more deeply. And off the back of that, students will, the way that we recommend it and the way that our lessons are structured is students have to write sort of 4 or 5 questions that they come up with off the back of that stimulus. Then they come and work together in small groups and start to categorize their questions into themes. And we've got a bit of scaffolding in the lessons to support that categorization. And then you come back as a whole class and see what each of the groups have that's similar or different. And, we love working with teachers who then keep these question boards up on the wall for the entire unit because you can tick off those Post-it note questions and you've got student inquiry driving the learning throughout the unit. We do have prompts sort of as we go through the unit that remind teachers, okay, let's go back to that driving questions board and see what we've learned and what we still have to learn. And do we have any more questions that we want to add to it?
Right. Okay. Very good.
Yeah, I just want to add in, going back and putting my teacher hat back on, I think about what really great instruction looks like. And first and foremost, it's finding ways to engage the students and to make it real for them and to get them some buy-in. I was just in a classroom 2 weeks ago, and we were going through part of our cells unit and talking about the phenomenon that drives that unit, which is the idea of would we want to eat meat that's grown in a laboratory? And thinking about this, bringing that student voice back into it, I found myself falling back in love with the craft of teaching in that moment because the students are, no, that's gross. I definitely wouldn't want to do that. Or then we're polling the kids, would you do that? But then taking that phenomena and grounding yourself in it, but then driving even deeper. Okay, maybe at the surface level, this idea of of meat in a lab is gross and off-putting and you wouldn't want to do it, but let's talk about the why and the how and why this might be significant and important. And then the kids, you can literally see their brains turning and moving. And so again, coming back to grounding those kids in that phenomena, immediately engaging them, it's going to get them that opportunity and the desire to dive deeper and ask those questions.
Yes. So was there a consensus among the classroom that would they eat meat grown in a lab?
I would say it was about 50-50. However, I will say that there was a significant portion of students who out the gate said no, but after some conversation changed their thinking and had a little bit of a deeper understanding and empathy for that idea.
Yeah, learning moments. Absolutely. So, and I'm thinking back to my time as a science student, and even I taught science. I taught 6th grade science, and how I taught science, and probably how all of us learned science. And for the teacher that is so ingrained, perhaps, in the scientific method, where you have a hypothesis, you test your hypothesis, you go through an experiment to confirm or deny whether the hypothesis is true. So those teachers that are like, I don't know about starting off with such an inquiry-based classroom and a driving question board. I was grounded in that scientific method. What are your thoughts, recommendations for teachers as they start to think about, okay, how do I evolve my classroom practice based on what a new generation of students need when they learn science?
Yeah, awesome question. I feel like there's a lot of interesting discourse around the scientific method. And is it related to this transition to this 3D way of learning through the NGSS, which sort of the foundations of, I'll sort of go back and sort of tell the story to kind of, and we'll get there, but the foundations of the NGSS were laid out in a book called The Framework for K-12 Science Education. And this framework really sort of stepped away from this idea that there is one scientific method, and instead said that there's a lot of different ways to be a scientist, but these are the general skills and practices that scientists use on a day-to-day basis. And that's basically how the science and engineering practices spilled out. And like, I wouldn't say that SEPs are replacing the scientific method. I think that they are just a more generic, bigger umbrella under which the scientific method can sit. And I think it's also, my experience in the classroom and as a researcher is like, a lot of the time, my experiments didn't actually fit into the neat, tidy box of the scientific method.
Right, yeah.
That actually be a little bit more convoluted than that a lot of the time, especially when you're doing field work. And your experiments got better and better and better as you learn more and more as well. So I really like this idea that there's actually a bunch of practices that scientists do on a day-to-day basis. And one of the biggest ones is communication and teamwork and these kind of more soft skills as well. And the sort of 3D classroom or the NGSS classroom is one that's sort of perhaps having a bit more of an equal balance across all of those different practices and skills.
Yeah, you think about all of the scientific discovery. We're in the first in flight state in North Carolina. I mean, if the Wright brothers were following that scientific method exactly, would they have been first in flight? There probably was some inquiry that they had to, and penicillin, right? Penicillin was discovered by accident even. So
I love that. Yeah, exactly.
Be careful because there's a question about the Wright brothers at our trivia tonight.
Oh, so look out.
We can't give away any answers.
Yeah. So just a plug, probably whenever you're listening to this, the trivia night will be over, but Stile is sponsoring a trivia for our teachers. So we have some trivia teams out there. So sharpen up because they may come back with another opportunity down the road to participate in some trivia.
And Heath, if I might just pop in just really quickly, I think you mentioned the scientific method, but just to push back a tiny bit, I don't necessarily think even it's just the scientific method in itself. It's also the way that we're presenting it. And you look at an elementary classroom and the way that our elementary teachers are presenting the scientific method to their students. Yes, it's that process, but it's also so much inquiry-based. And also phenomena-based, because again, how do we get those kids to want to learn this? And so I struggle oftentimes with that transition from elementary to secondary, and sometimes our teachers aren't as willing to allow the students to pull in some of those strategies and skills that we let our elementary kids do. And I really do think Stile does a great job of emphasizing that student discourse and student engagement and student autonomy that sometimes that sit and get won't allow for.
Yeah, absolutely.
I don't think it's don't teach a scientific method. It's yes and
right.
Let's do more.
Very good. Absolutely. So we talked about that 3D kind of model the 3 dimensions. And so talk to us a little bit about those 3 dimensions of the next gen science standards.
Yeah, for sure. So we've got the DCIs, the disciplinary core ideas, which is like your core content matter. Understand like how a food chain works, for example. Then you've got your science and engineering practices, or your SEPs, which are those things like analyzing and interpreting data, developing and using models, asking questions and defining problems. And notice that there's the engineering practices are entwined, not just scientific practices. So there's a much greater emphasis on engineering skill sets in the NGSS. And then we've got the cross-cutting concepts, which are themes that work across scientific disciplines, things like cause and effect and patterns and systems and system models. And so there's 7 cross-cutting concepts and there's 8 scientific and engineering practices, and there's many, many, many DCIs. But I do believe for the North Carolina science standards, they've just incorporated the science and engineering practices for now. And the cross-cutting concepts are sort of nice to have. If that's something that you can bring into your practice, that's awesome. But I don't believe the state has said everyone has to cover those cross-cutting concepts.
I've heard some leaders describe the North Carolina standards as 2.5 dimensional.
Okay.
The cross-cutting concepts are in many ways incorporated, but not necessarily assessed in the way that we might anticipate.
Okay, very good. And so when we think about those and really, so how do teachers unpack that? Knowing that you have these cross-cutting concepts, you have this 3-dimensional model, what recommendations, what advice would you give to teachers as they're designing lessons, designing instructional activities to help meet some of that criteria?
So if I didn't have curriculum that I loved, then I would go to the standard and I would get 2 colors and I would highlight the DCI, the disciplinary core idea, what's the main thing my students need to know in that standard, and then I would highlight the science and engineering practice. What's the sort of way that they're going to show that standard or that DCI? So are they using a model to, once again, explain how food chains and food webs work, or using a model would be that science and engineering practice, and the food chains and food webs piece would be the DCI. So, and I'd start there, and then I would think about what my assessment needs to look like in order to know if kids have mastered that standard, and then I would backwards plan off that assessment to fill in the gaps of my teaching, week by week lesson planning. But if I had a really great curriculum, hopefully it's already done all that for you. And so that's the case with Stile. We have a teacher guide where you can see which Stile unit is going to cover which North Carolina science standard. And then you can have a look at the assessments and you can see the 2-dimensional or 3-dimensional assessment all the way down to a question, as well as have model answers for that. And then all that backwards planning is kind of done for you. But you can also, customize it and change it to add your flair and make sure that it's going to reach all of your students.
So, Mark, when we think about those science and engineering practices, and for example, using the models, so in your experience, when you, for example, visited a classroom or when you were teaching in a classroom, what are some of those science and engineering practices that we should be looking for when we go into classrooms, that we should be trying to make sure that are evident that the students are engaging with?
Yeah, so before I even jump into that, I think one thing to keep in mind, Heath, is that sometimes I see teachers when they're looking for the science and engineering practice or when they want to incorporate them, they're trying to do it in isolation. And I think it's really important to know also that when you're providing good instruction and you're teaching these science concepts well, you're going to hit on multiple SEPs at once. Just in my time in the classroom last week, I saw students analyzing and interpreting data. We're looking at graphs. We're looking at data that the students collected based on a investigation that they were performing and a demo that the teacher was showing. The idea of communicating that information with each other. So multiple ways in which students will have opportunities to take what they've noticed, take what they've learned and observed, or what they've analyzed, and then communicate it and share it across the classroom, collaborating with each other. I think you had touched upon the idea of analyzing or using models to provide information, and so I think when we're diving into that, it's also important to looking at that SEP, but then me as the teacher, how can I take that and make it accessible for all of my students as well? So thinking back and leaning back on my time with special education and EC, I saw this one teacher do a great job of, okay, I know that we need to perform a model, but that's going to look different for each of my students. Some of my students want to do it in one way, whether it might be using something with their hands, and other students are really great at using numbers and technology. Other students are really great at, I'm just going to draw this model because this is how I express myself best. And so I will, just another big shout out, Heath, is that your teachers so far who have been utilizing this curriculum have done a phenomenal job of not only sticking to what Stile wants to represent and be, but also taking what Stile is and what that curriculum is and adapting it to their kids and making it their own.
I'll just add there. I know you're not supposed to have favorites, but my favorite science engineering practice is definitely developing and using models. And I think it's also the one that's kind of maybe most teachers would be least familiar with. A lot of the others are, communicating and, planning experiments and that sort of stuff. You kind of got under your belt, but developing and using models, it's kind of new. And I think the thing I love about it is it's really creative, and kids have to try and show their thinking in their brain and put it out on paper or into the world in some form. And it's particularly cool when you get kids to develop an initial model at the start of the unit. So like our waves unit, the guiding question is, how do we see and hear each other on the other side of the world? So how does a video call work? And kids have to, right at the beginning of the unit, try and draw out how they think a video call works. And they learn a little bit more about light and they iterate on that model. Then they learn a little bit more about sound and they redo their model again. And then they learn about digital communication, analog digital signals, this sort of stuff. And then they get to create a final model as a group.
Yeah, that's great. And I really feel like part of that developing and using models is pushing that rigor to a higher level, because I think you're right. I think initially teachers are going to say, oh, well, I have students design and create models. We do a model of the solar system, right? We've done that for 40 years. We create a solar oven to model thermal energy and all these different things that we do. But is that really what developing and creating a model is? Is it sometimes less complicated than that, or is it sometimes something a little different? And so I think there's some new learning or some relearning that might have to take place with science teachers and administrators that are understanding really what some of these definitions for those SEPs are.
Oh, we fight about it all the time at Stile. Is a diagram of a cell a model? And the most common answer that we come to is it's kind of like Bloom's taxonomy or Solo taxonomy. It's like if you're just putting labels on a model of the cell, that's kind of lower order. And if you were trying to construct a model of something that you have no idea how it works yet, and there isn't necessarily a right answer, then that's something way higher up that taxonomy.
Mark, did you ever grow up in a science classroom where you had to label the parts of a flower and and all of that? I remember back in my classroom days labeling parts of a flower, and then you got the color of the flower. So is that really using a model or creating a model?
I've labeled a flower. I've labeled a human cell, a plant cell. I've labeled humans. I've labeled everything ever. Yeah. And if you asked me to sit down and tell you the parts of a flower today, I would tell you there's the petal.
Yeah, that's right.
And that's about all I know.
Right, yeah. And so I think that's where, when you're really using those models, it's pushing that rigor and having the students take some ownership for that. Now, I know teachers are saying, well, what's wrong with having them do that? There may be a point in that, but it's what you do with that what's next, and how are you going to elevate their thinking. So I love that, which is really part of this idea of promoting a deeper understanding of scientific concepts. And so how do the SEPs really promote that deeper understanding? What does that look like in a lesson? What is a teacher really strategically doing to promote that level of understanding, that level of learning that is far deeper perhaps than what we've ever experienced in science instruction previously?
I'll toss it to you, Kat, in a second, but I just want to, you had mentioned that developing and using models is one of your favorites, and I just kind of want to go back to the SEPs and talk about the idea of asking questions and encouraging that dialogue amongst our students. And you think about middle school kids and what do they want and how do they learn best? It's when they can make it personal and when they can have opinions and inject their ideas. And so, to go on your question, Heath, just isolating that idea of asking questions, and I think that really will engage the kids in talking about their thinking and analyzing their thinking and sharing their thinking with each other. Kids also sometimes learn best when they're learning from each other and not necessarily the adult that's standing in front of the room.
Yeah, I mean, and I think whenever we're talking about students being able to take ownership of some of those questions and however they monitor that or however they reflect on their learning, science journals, I mean, it could be that driving question board that's available for going back and referencing throughout a unit of study or throughout a semester or school year. So what kind of resources help support that? And I know we talked about in Style having digital resources, print resources, but what are some, and a lot of our teachers use a science notebook and have always used that. And the students, in fact, I even know from my own experience with my own children, as they've went off to college and I've had to send them their chemistry notebook from high school because they needed it for their chemistry class in college, and it had all of that background knowledge that they had learned. And so they kind of, through that process, were creating and designing their own text in a lot of ways. So what does that look like for the Style curriculum, and more for a teacher that maybe doesn't have access to the Style curriculum, but if they're looking at creating some of those print resources for future reference?
Yeah, I 100% agree about this idea that you have to be exposed to something more than once to be able to remember and understand it. And the research totally backs that. I think they call it spaced repetition or spacing. And, the other powerful layer to that is when you do that piece of elaboration, which is where you personalize it and you make it your own, and you don't just rewrite the sentence exactly as it is, but you reshape it so that your neurons are doing the hard work. I always told my students, when they say, "This is hard, miss, this is tricky," you're like, well, that's good. It means you're learning. That's what's supposed to happen. So in terms of what, STAR does, everything we build, we do try to, we fundamentally believe, we're a science curriculum. It has to be based in evidence and based in cognitive science and how brains work and how humans learn. And so that does mean that our curriculum is shaped to mirror that process of learning. So we sort of see the digital platform is supporting maybe that first exposure where teachers are really supporting students to go from A to B and to scaffold them to that new knowledge. But then we have print workbooks, we call them Stile X, which is that space for students to make it their own, to review their work, to be exposed a second time, to get those multiple exposures, do that retrieval practice. I also got some really strong literacy support and numeracy support built into it. And it does a lot of it mirrors what interactive notebooks would do, but everything's kind of already done for you. You don't have to create the frameworks for it. The framework is there and ready to go.
Very nice.
And Kat won't say it because she's too modest, but Style X was her curation and baby.
She was one of the curriculum authors, correct? Right. Yeah. So certainly we're benefiting from having some firsthand understanding and knowledge of what inspired that and the content creation that makes up that curriculum and kind of its origin and its genesis. So certainly to our benefit to be able to understand some of that. And I'm thinking about even with the cross-cutting concepts and some of those next-gen standards, real world application and real world understanding of what's happening, locally or nationally or globally in the science, in the science world or in the student's environment. What role does that play whenever a student is developing their background knowledge, learning how to do science and to investigate the phenomena around them? Locally, some of those real world applications, what does that look like in our classrooms?
Yeah, so when anytime, and whether it's in science or math or social studies or reading, anytime that you could make it meaningful and make it matter in accordance to the students' and teachers' lives, that's when you're going to find the most engagement and the best types of learning. There's going to be a unit in Style that's going to investigate the idea of Lake Norman, some of the algae buildup and what that has produced and the quality of water and the idea of human impact on water and also the vice versa, the impact that it has on human life. And, we have local lessons based in Oregon, based on some of the local features and phenomena that they have in there. And then coming back, again, like I said, in North Carolina, we have taken purposeful steps and ideas in incorporating landmarks and features and science that is North Carolina specific. You don't have it yet, Heath, but our very new North Carolina periodic table is going to highlight 4 elements that are super local to North Carolina, including gold, which I know in my experience at Louder, we sent a lot of our little ones to mine for or sift for gold. And so going back to your question, it's how can I make it matter to me? If I'm learning about lakes over in Asia, like that's cool and that's great, but it doesn't matter to me. And so when I can talk about things that are local and meaningful, I buy in. I'm invested and I want to learn about it.
Yeah. I think you'll find most style units are kind of hourglass shape. So you're going to start with that real world big picture problem, and then kids will get really into the details and, iterating on models, asking questions, doing some really hard work, and then coming back out again, they're going to try and apply what they've learned to that big picture real world thinking. And the only other thing I'd add is, something we really pride ourselves on is that we stay up to date. You're not going to find a data set from 2012 in style. We have, alerts set up to tell us when the piece of data that we have is sort of beyond the age that we deem reasonable, which I think is like 3 or 4 years. And we'll go and update those lessons. And we release science news lessons as well on a sort of, every other month basis that are talking to what's happening in the science world all around us. And they're just these sort of quick, light, informative lessons that can just, make life a bit easier for teachers.
That's great. And so talk to me about the fish cannon lesson. I know that, so just as an example of one of what that looks like. So just tell us briefly a little bit about the fish cannon lesson so that teachers maybe can get a taste of all this next gen science standards, phenomena-based learning, anchoring questions, all of this that we're talking about. I mean, let's bring it to a real lesson. One that I'm familiar with is the fish cannons.
Yeah, you tell about the fish cannon, I'll tell a funny story to follow up.
All right. So the fish cannon lesson is a lesson in our unit on energy conservation, which is grounded in this phenomena of dam removal over in the Pacific Northwest, but then one of the biggest dams in the world being built over in, I believe it's the Democratic Republic of Congo. And there's local experts sort of taking us through these 2 contrasting case studies. And at the end of the unit, kids do a Socratic seminar to try and explain why dams are being removed in some areas and built in other areas. But the fish cannon lesson comes in because kids are investigating some of the environmental impacts of dams, and one of those impacts is on fish, particularly salmon migration. And some scientists in the real world have come up with a solution to get fish over the dams by essentially putting them in a big tube and using pressure differentials to push that fish through the tube and over the dam. And I definitely recommend, John Oliver does a really good segment on salmon cannons, can recommend watching that one. But the lesson is kind of structured with kids like watching a video of this salmon cannon, and then they have to build a model of the salmon cannon in the classroom. And so we have a sort of suggested equipment list where we use elastic potential energy rather than those pressure differentials to get the salmon, which are these like little printed salmon cards that you use the elastic band and you kind of shoot them as far as you can. Kids collect a bunch of data looking at if we build up that elastic potential energy by stretching that elastic band more, what does that mean for our data when we do replicates? And we can talk about accuracy and precision then. And then the lesson ends by just talking about, do we think this is a good model of a salmon cannon? What are its strengths? What are its weaknesses? How could we make this a more accurate model that better reflects how these engineers have designed the real world salmon cannon? And is it stepping back, starting to solve these problems around dams, or is it not?
Yeah. So thanks, Kat. So just really quick, I was in a classroom recently, and they were doing this investigation, and one of the groups of students who was running the experiment, they went to release the fish using the fish cannon, and it went really high and hit another student, I think, in the back of the head. And not only was that really funny, but it also sparked like this really weird and sudden conversation about, what if this happened to the salmon? What if they hit each other? Well, they say that those fish cannons don't cause stress. And so it was just really funny to see how an experiment or investigation sparked even more conversation amongst the kids.
Yeah.
And it was a really great laugh.
Yeah. So, and that's really interesting because a student, you don't think of jobs and careers that might be related in the science world about launching fish and making fish cannons and using that kind, but it's out there, right? I mean, somebody really has a job that's their responsibility is to use these fish cannons to get salmon from one body of water to another?
Yeah, 100%. I mean, I really wish that one of the SEPs was like creative thinking. I mean, it kind of is because like it's just not explicitly there, but I honestly think it's one of the biggest skills that scientists need to be able to solve these gnarly, really interesting problems in the world. And some scientist or engineer, they sat down and they were like, well, why don't we just chuck them over the top of the dam?
Yeah, right. And so, which leads us to another thought, careers related to STEM and science. Are there any resources, activities within the STILE curriculum or that a teacher could use that would help emphasize some of that? Because we know, obviously, it's getting more difficult to find not only science teachers, but scientists in the field that are doing some of this work. And so we do try to focus on some of that career exploration and opportunities for discovering some of that. And Mark, you mentioned how the durable skills and some of the next gen standards help develop that. So what does STILE intentionally do, or what can a teacher intentionally do to integrate some of that career exploration into their science classroom?
So in addition to what a teacher can do, STILE does that for you. Every unit and lesson has career profiles that drive some of the dialogue and conversation around the core ideas and the core concepts. So going back to that cells unit lab, we identify an individual whose job is working in the labs and how they've thought about this idea and the background that they have. We also have some additional resources that we highlight women in STEM and just bringing some attention to some women that are doing really phenomenal things in the STEM community. I know locally, we're really hoping to collaborate with some local institutions, including Duke Energy and some other organizations to highlight what are the great things that are happening here in North Carolina. Who are some leaders here in North Carolina that are spearheading our science learning and our science practices, and how can we give our students and teachers access to those people and show that this is a career path that's definitely an opportunity for you.
Absolutely. And the one thing that you will notice when you look at STILE career profiles is they're not all of career scientists. Once again, you're going to find people who use scientific thinking every day in their job, but they might be a chocolate taster, or they might be a pizza chef, or just one's a scuba diver. We're not talking about just the sort of mainstream scientist jobs. We're talking about people who are going to be using science every day, no matter what their career is.
That's fantastic. So in our region, just as reference, Kat, and something, Mark, you might have learned since you've moved down here, a couple of industries, NASCAR is huge. And so, Kat, I don't know what kind of auto racing they do in Australia, but I know they have some open
F1,
course.
you think?
Yeah. So in North Carolina, it is NASCAR. So there's a good opportunity to tap into probably some lessons related to NASCAR. And then, of course, also the furniture industry is pretty big in our area as well.
Is this why there's giant pieces of furniture all over?
Probably so. Yeah.
The few little road trips I've been doing, I've seen some big chairs.
Yeah, that's right.
Some big,
they're very
dresses.
It's great
Hickory up in Hickory,
right? Yeah, great opportunities for photos of sitting in those big giant chairs. But so the furniture craft has always been, and there's others, but those are a couple of regional ones that certainly provide a lot of opportunities for some integration of careers.
I brought Kat by the Concord racetrack a couple weeks ago.
Yeah, right.
We should definitely drop a line to the product team about NASCAR and the kinematics unit and see 100%. If we can get some more NASCAR in there.
Design some cars.
Yeah, right. Absolutely. Well, and if you haven't made a trip to the NASCAR Hall of Fame, you can actually go and practice putting on tires on a race car and seeing how fast you can do it.
We'll have Kat do it, and we'll take some videos and send it to you.
There you go.
Terrible idea.
Marketing team, you've got an opportunity to get some pictures at the NASCAR Hall of Fame of Kat doing a pit stop. So excellent plan. If you have any spare time, I think you're in a quick trip, but maybe next trip if you haven't got it in your agenda for this one.
Maybe next trip.
Yeah. So it's a new teacher that's perhaps listened in or is new to teaching science. Sometimes, particularly in elementary, they may not be a content specialist and are nervous about teaching science, and even in high school, they may be a biology teacher and that's their passion. And just because of how the schedule falls, they're going to have to teach a section of chemistry or physics. And so how can a teacher that's new to using the next gen standards and the SEPs? What can they do? And what's some advice you would give just to initial implementation of that?
Yeah, so I mean, there's background reading. Like you could skim the framework for K-12 science standards and so that you kind of understand the foundation. It's quite a read, but like flicking through it, you'll get a good gist of it. Ambitious Science Teaching is another excellent book that gives you like really practical strategies about how to sort of embrace the philosophies that underpin the next gen science standards. And then in Stile itself, we really pride ourselves on giving new teachers the support they need and then veteran teachers the flexibility they deserve. And so in terms of that support that new teachers or out of subject area teachers might be able to get, we've got these incredible teacher resources. So you're going to have a full scope and sequence with all of your standards aligned to Stile units when you're planning for your year, and you can sort of figure out exactly which unit you're going to teach when. You then, at the unit level, will have what we call a unit plan, and that's going to have week-by-week lesson planning for you, which is actually editable. So if you do want to add or remove lessons, you totally can. But very high detail, telling you exactly what that unit flow and unit structure is going to be down to a day-by-day basis. And then at the lesson level, in each Stile lesson, you can expand and contract teacher tips, which are going to give you in-the-moment teaching suggestions. So it might be an opportunity for differentiation or an opportunity for collaboration or discussion. And so you can read those through in the sort of the night before class or the week before class, or the few minutes before class, depending on how organized you are that day. And that will just give you an idea of the sort of flow of the lesson as well as things that you might want to change up as you go.
Very nice.
Anything else?
I just think I can't help but think about how important the administration and structural buy-in to a curriculum and resource is, and I just want to say from the inside and outside perspective, for the kind of seen a little bit both, I think Lincoln County is going to be set up for unbelievable success because whatever curriculum you put in front of your science teachers, you know that it's going to be backed up and supported by everybody district-wide, including just this podcast right here, just the amount of resources that your teachers will be able to tap into to be successful.
Yeah, and Kat, I think you mentioned, so giving new teachers the support they need and veteran teachers the flexibility they deserve. So for a veteran teacher that's still growing professionally and still adapting and learning, so professional development for that veteran teacher, I mean, what does that look like? What would your recommendation be for that veteran teacher that says, I've been teaching science for 22 years, I've got this. So how do they continue to grow and still refine their practice to be up to date with what science instruction looks like?
Yeah, 100%. And, the beauty of Stile is that everything is customizable. So you're given this really strong foundation. But if you always use this video and you love it, then you can go and pop that into your lesson. But, at the same time, you look at a Stile lesson and you're like, oh, this is a new way of doing things. I haven't done it like this before. And so for veteran teachers, the step one is still like becoming really familiar with all of the resources at your fingertips, because you don't want to have to do extra work if Stile's done it for you. So step one, your first training or your first PD is just, getting familiar. We help you with a bit of lesson planning, unit planning, and veteran and new teachers sort of both come together for that professional development. From there on, we can sort of break you into streams where new teachers perhaps are looking at slightly different things to more veteran teachers. The PDs that have been really, really successful for our more experienced teachers are ones that really focus on these new sort of, not necessarily brand new, but like slightly different approaches to learning. So we've got PDs on driving questions boards. We have PDs on the science and engineering practices and how to bring them into your classroom every single day. We have a PD called Teach Your Way, which is all about thinking about the kids in front of you and what that means you can do in like even just 5 minutes before class to adjust that Stile lesson so that you're reaching more of your students. So really focusing on differentiation, but differentiation that's like a relatively easy lift. We also have PDs that really look into the data that Stile's going to produce for you. And if the district has strong PLCs coming together and looking at that data, that's something that Mark can come in and support with. And then the final piece that I found all teachers find really, really helpful is having someone on the Stile team come in and take your kids for the day or for a couple of periods. We call them demo days, and it just brings so much conversation forward, and you watch someone else take your class and you're like, oh, that's awesome. I'd love that. Or, oh, no, I wouldn't do that with that kid. And everything in between. It's just this really sort of open and honest learning process when you are doing something that's a bit new.
So I think probably as we start to wrap this up, I was in listening to both of you talk, where do you see science instruction evolving to? I mean, what is it going to look like in the future? And how do we prepare our teachers and our students for the future of science and the future science curriculum? Any thoughts?
It's a great question. Did you want to jump in?
I love that question so much. And I don't know the answer, but the reason why I'm so passionate about science and science education is because science is that discipline where when we learn something new, we actually change our mind. It's changing all the time. And that means that if science is a discipline is going to change all the time, that means science education will too. And, as we learn more about how our brains work, that means that classrooms will evolve as well. Personally, I see a future of science education that looks more and more responsive to our students and their needs. And I think that sort of comes down to there isn't one way to do everything all the time. I think our kids are going to need lots of different approaches, which means we as teachers need to be a little bit light on our feet and make sure that we're spending our time on the most important thing. Those are some of initial ideas. What do you reckon, Mark?
Yeah, and Heath, you can empathize with this probably more so than anybody, but in my experience in classrooms, when you look at science has always been kind of the cousin on the outside looking in. How many teachers are in the middle school or high school level, and you're pulling from teachers pay teachers or this curriculum or that curriculum because you don't have something in front of you that's the total package. And we think about how important science is to our students and to the workforce and to just the community in general. And to think that we've historically haven't had anything that you can give to a teacher and confidently say, this is everything that you need. And so I'm really excited, number one, that North Carolina has emphasized the new standards and put work into putting something in front of the teachers that they know is going to produce science capable and fluent students. But also, you say, what's the future of science education? Well, my hope is that Stile is the future of science education, not just North Carolina, but across the states, because what we offer is exactly that. It's that total package. And I'm really excited to be able to walk into a classroom and give it and confidently look a teacher in the eyes and say, this is everything that you need, and you can now fly with it because you deserve something that's going to highlight your strengths as an educator.
Absolutely. Yeah, and I think probably all of us have been guilty as teachers or classroom teachers at some point. I know I have been, where you have that day where you come in and teachers are tired, right? Mm-hmm. I mean, they work so hard and they spend all of this time investing in their instruction. And so you have that day where it's, open to page whatever in your book, answer the questions, define the key terms, or we're going to watch this video and answer questions related to this video. And it's not that teachers don't want to have that really engaging science lesson, but to bring that, and that's why they go to teacher pay teachers and some of these other resources. They're just tired and they don't sometimes have the time that they need. So I appreciate the work that Stile is doing to help support teachers with those resources.
The amount of Bill Nye videos that I've watched.
Sure, right, yeah, absolutely.
And I think that's okay as well. It's okay to have quiet, calm days like that where kids are just thinking deeply, but you got to pair it with the other stuff. Right?
Yeah, and that's the good thing about the next gen standards. There's flexibility for how those teachers teach that deeper learning, and it's not just you don't always have to have the dynamic lab activity that we think of science classrooms. Students automatically go, we want to blow something up, or we want to, right? I mean, that's where they go, and sometimes it's not that, and that's okay as well.
And I think just one last point on the future of science education and where that's going. I think, the aim of science education has to be about creating that next generation of problem solvers and critical thinkers who are going to help us solve tomorrow's problems. And I think that if that's our North Star, then all of us science educators, everyone working in science curriculum, we need to be pointing at that North Star and being okay, what do our kids need in order to be able to get there, to be able to do that?
All right, y'all. So what's next for Stile? I know middle school is your space right now. Probably our elementary teachers, high school teachers our listeners might be saying, okay, sounds great. Will we ever see a space for K-5 or 9-12 with Stile, or is right now middle school your baby? That's your passion, and we're going to perfect that, and then we'll see what happens next?
We definitely are middle school specialists, and I think we forgot to mention that the state of North Carolina has sort of recommended Stile for approval as the only aligned middle school science curriculum from grades 6 through to 8th. Having said that, we definitely want to keep growing, and I think high school is next on the list. So, in fact, as soon as 2025 school year, we should have a few pieces in our that are building out our high school offering. We already have a bit of a supplementary high school curriculum, but we want to try and get that comprehensive, maybe in time for the next school year, maybe the school year after that. And then elementary would be awesome, but I think it's bottom of the list right now.
Right. Yeah. Any final thoughts? Any closing words or recommendations for our teachers and our listeners that are, because of this, passionate about what they do every day and are now motivated to get back to their classrooms?
Yeah. So for me, Heath, everything I do, I ground back into my family and my children. And as not only am I a former Lincoln County educator, but I'm a stakeholder here as I have children in Lincoln County schools. And I think if I, take this for what it's worth, but if I am proud and confident to say that we could be bringing something really special to Lincoln County in Stile, then what I'm really saying is I want that for my kids as well. And so, Heath, I know you have kids, and you can speak to the importance of that. But my son's at home all the time, and we're wanting to do experiments with elephant toothpaste or this or that, and I just think I'm so excited to see Stile bring the science back into teaching.
Yeah, that's great.
And just a big thank you from me to all the teachers working your butts off, because it's hard work and you're doing a great job.
All right, Kat, Mark, thanks so much for joining us today, and we look forward to future conversations about science. Thank you for being here. Listeners, thank you for tuning in. Join us next time on Science Power Hour as we continue the conversation about science instruction in our classrooms.
And also follow us on our Stile Education socials, Facebook and Instagram. We'll have a bunch of good competitions, prizes, events, etc. there for you to have a squiz at. Stile Education USA.
Don't forget to subscribe so you never miss an episode. And if you're looking for renewal credit, be sure to fill out the form linked in the show notes. We'll catch you next time on the Science Power Hour podcast with more insights and strategies to boost your science teaching.